This program is made by the volunteers at Math Circle Online. Please join us to explore the wonders of math.
Hi, I'm Oliver Jiang, and today I'll be showing you how to solve problem number 18 from the 2015 AMC 8. So the problem reads, an arithmetic sequence is a sequence in which each term after the first is obtained by adding a constant to the previous term. For example, 2, 5, 8, 11, 14 is an arithmetic sequence with 5 terms in which the first term is 2 and the constant added is 3. Each row and each column in this 5 by 5 array is an arithmetic sequence with 5 terms. What is the value of x, which is in the middle over there? So for this problem, we're going to need to recognize a couple things about arithmetic sequences. So if you're given an arithmetic sequence, if you're given any two terms in the arithmetic sequence, you can find any of the other terms. So if we use the example sequence, let's say we're given the first and last terms, so 2 and 14. So it tells us that in any arithmetic sequence, there is a constant term that you add to each term to find the next. So let's for now call that constant d. Okay, so if the constant is d, then the second term should be 2 plus d. The next term should be 2 plus 2d. The next term is 2 plus 3d. The last term is 2 plus 4d. So basically, from here to here, you increase d. From here to here, you also increase d. From here to here, another d, and another d. So for the last term right here, it's both 14 and 2 plus 4d, so we have an equation. So our equation is 2 plus 4d equals 14. So with this equation, we can solve for d. So 4d equals 12, so d equals 3. So now that we know that d is 3, we can find the rest of the terms. So this one is 5, this one's 8, this one's 11. Okay, so in this grid right here, there are several arithmetic sequences. The ones that we're going to use is this column right here. If we use this column, we can find this term right here. We can also use this column to find this term right here. And if we're given these two terms, this is also an arithmetic sequence, so we can find x. Okay, so looks like we're going to use a lot of arithmetic sequences. And there's something in common with these sequences is that we're given the first and fifth terms. So let's create a general case for this. So So the thing in common with all of these arithmetic sequences is that we're given the first and fifth terms. So let's call these terms A and B. Okay. B can also be written as A plus 4D because 1D, 2D, 3D, 4D. So if we know that this is both B and A plus 4D, we can create an equation. So A plus 4D equals B. So we're looking to solve for D, so 4D equals B minus A. So D equals B minus A over 4. So this is going to be useful for the rest of our problem. There's also a commonality in all of these arithmetic sequences is that we're looking for the middle term. See, this is the middle of this one, this is the middle of this, and x is the middle of this row. So it'd be useful to write the middle term out in terms of A and D. So the middle term is just A plus 2D. Okay, so let's use these now. So for the first one, it looks something like this. Okay, so the first term is 1, the fifth term is 17. So using our formula, d equals the last term minus the first term over 4. So d equals 4 after you simplify this. So if d equals 4, we can find the middle term. So the middle term is 1 plus 2d, or 2 times 4, which equals 9. So this 9 goes right here. So this is 9. Okay, so now let's work on this column right here. Okay, so the first term is 25. The last term is 81. If we use the formula, the common difference, d, is last term minus the first term over 4. So this turns out to be 14. Okay, so now that we know what d is, we can find the middle term. So the middle term is just the first term plus 2 times the common difference. So this equals 53. So this right here is the middle term. This is 53. So the middle term is right here, 53. So now we have one more arithmetic sequence to go through. So the first term is 9. The last term is 53. So once again, using our formula, d equals 53 minus 9 over 4. So after you simplify this, you get d equals 11. So once again, we can find the middle number with 9, the first term, plus twice the common difference. So this equals 31. Okay, so the middle term is 31. So the middle term x is 31. So our answer is B. So there's actually a shortcut in this problem. For each of our sequences, we found the middle term by finding a plus 2d. And to find a plus 2d, we had to actually solve for d. We didn't have to do any of that. There actually is a property in arithmetic sequences where if the length is an odd number, in our case 5 is an odd number, we can find the middle term by simply taking the average of the first and last terms. So for each of these, you could have done a plus b over 2 to find the middle term, which is a lot easier. So thank you for watching.